and knows that water goes downhill. What will happen when and we can see what happens where two lakes at different levels are connected. But what about oceans? Do they behave the same way? Determining the true level of the sea is not as simple as it might seem. The surface of the ocean is never at rest. Its level changes with each passing wave. Tides also change the level of the sea. This drop of 7 feet took place in 6 hours. Because of such constant fluctuations, the true level of the sea can only be determined as an average. This average is computed from long-term records. Stations have been set up along the shores of oceans all over the world to record changes in water level. Each measuring station houses an instrument called a tide gauge. A pipe extends from the tide gauge station down into the water. In this model, we can see how a float rides up and down on the water inside the pipe. The float responds slowly to changing levels outside the pipe, thus automatically averaging the effects of small waves. The float is connected to a pen that traces a continuous record of the changing level of the sea. One day's tide cycle on the beach just seen looks like this. Another day like this. And still another day like this. Obviously, the tides are not the same every day. One day's tide cycle on the beach just seen looks like this. Another day like this. And still another day like this. Obviously, the tides are not the same every day. So to find the true level of the ocean, we have to know the average of its changing levels over a period of many years. This long-term average is called mean sea level, and it is from mean sea level that all land elevations are measured. Since all the oceans are connected, one might assume that mean sea level is the same everywhere. But is it? At Panama, the Atlantic and Pacific Oceans are only 50 miles apart, a good place to compare sea levels. Tide gauge records from each shore show that there are times when the difference in level between the two oceans can be as much as 12 feet. When the tides are averaged over a period of years, mean sea level on the Pacific side is found to be 9 inches higher than mean sea level on the Atlantic side. How can we account for this when we know that all oceans are connected? What natural forces can hold the surfaces of oceans at different levels? This tank represents a large body of ocean water held at different levels by a divider. When we raise the divider, their levels equalize. But if we fill one side with cold water and the other side with hot water, to the same level, and then lift the divider, we find that the cold water is a little heavier than the warm. The two connected bodies of water balance each other at different levels. Now let's add salt to the water on one side and add fresh water to the other side until both are at the same level. Again, when the two are connected, they maintain different levels because salty water is heavier. This time, with the divider lifted, if we increase the air pressure over one side, we force the water down and the other side rises. Water levels can also be affected by air currents. When water piles up against a barrier, its level rises. In nature, differences in water level result from the same causes. For example, cold water carried by ocean currents meets warm water. Fresh water from heavy rainstorms can change the saltiness of the seas. Large rivers do the same where they empty into an ocean. The ocean surface is slightly depressed under areas of high atmospheric pressure. Where the pressure is low, it rises. Where strong winds pile water against a shore, sea level rises. Because these and other forces are at work on all the world's oceans all the time, mean sea level differs from place to place, which explains why mean sea level is higher on one side of Panama than on the other. This difference in mean sea level does not affect the operation of the Panama Canal, because the canal does not connect the waters of the two oceans. Through a system of locks, ships entering the canal are raised 85 feet from one ocean to an inland lake. They are then lowered through other locks to the opposite ocean. Each lock delays the movement of ships through the canal. So, for many years, engineers have been studying the feasibility of a sea-level canal that would have no locks. Such a canal would connect the waters of the two oceans, and that raises some interesting questions. What effect might the 9-inch drop in mean sea level have on such a canal? And what might daily tidal changes do to the water in the canal? What other forces at work on the world's oceans might affect sea level? That water goes downhill. What will happen when... And we can see what happens where two lakes at different levels are connected. But what about... knows the oceans. Do they behave the same way? This drop of 7 feet took place in 6 hours. Because of such constant fluctuations, determining the true level of the sea is not as simple as it might seem. The surface of the ocean is never at rest. Its level changes with each passing wave. Tides also change the level of the sea.